Alright, in this video you're going to see two different exercises. The first one is going to be the exercise that shows you how to create the shape. Then I show you how to create the dome like this. So this was an inspiration from the Pantheon, and this is the design where we have a dome and we have these boxes that are offset and inserted within the dome. And so that is the exercise that you'll see here. It's going to be mostly creating the dome shape, which is going to be here. Then we move on to subdividing it using isotrim. And from there, we create a few sets of offsets here to create that facet. And then from there, we put it together into the form by joining it together using brep join. So what you're seeing here, it's not actually Boolean difference or subtractions from the dome form. This is actually additive. So we create all of the details you see here. We start with the exercise, then we move on to this dome. So that's what you'll see here. If you want to download this, go to my website, capettidavid.com. There you can download this script. You can find other resources and you can get in touch with me if you have any questions. So hopefully you're excited to learn about a little bit more about parametric design and how to create this dome. The techniques you'll learn here can be useful for many other designs. All right, so the first thing we'll do is bring in a rectangle. Now, there are different ways we can do this, but this example is just going to be using this rectangle where we can place it here on the plane, which it's already at the origin plane. Now we can change the X and Y size. So I'll go here to 15.5. This gives me a slider and I can use the X and Y to pick the size of the rectangle. Now the aspect ratio is not that important. So with this, now we need to create an offset. So the example here would be to bring in an offset component using the offset curve. We can plug in the rectangle into the curve input. Now it's offsetting to the outside. So we could do two different things. We could either go -15 ... 0 ... 15. That gives me a custom slider, or I could just go 15 and then bring in a negative, because if I plug this into the positive, it's going to continue offsetting to the outside. So now using a negative value, we can change that. And now it's offsetting to the inside. Now this number is a little bit too large, so the maximum is 100. I'll change that maybe down to, I don't know, 20. So notice that we only have one offset. If we wanted to create more offsets, we could copy this, plug this in, copy this, plug this in, and then create offsets this way. But this is not scalable in the sense that if I wanted to just add one more, I would have to copy this over and do it again. And since this is not necessarily the best approach, but that is technically how you approach it when you do 3D modeling, is you would just create an offset, create an offset, create an offset. But with this one, we are now going to be using a different component. And this is part of the exercise, is learning what this component does, which is the series component. Now the series component, what it does is it creates more than one number at once. That's all this component does. Now with a slider, we only have one input. So if we want to create a series or a set of numbers, how could you do that? Well, we can say starting at 0, stepping by, we'll go here, -2 in the step. And now for the count, we can change this number. So if we only want 5 offsets, it's going to create multiple numbers. So when I bring in a quotation mark or a panel, you'll see that when we plug this in, it does exactly what we wanted. It started at 0, so that's a start. Steps by -2, so 0, -2, -4, -6, -8. That makes sense. And count is 5, so we can add more or less numbers. And this is how we would actually create the series of offsets here, is by using the series component, we can decrease the step and we can add more offsets. And so we'll use this as the example. And now what we need to do is create the rest of the script. The next portion is going to be turn this into a 3D offset that looks a bit like a pyramid. All right, so now that we have the offsets here, we're going to take these and we're going to extrude it up. So I'll bring here an extrude component. And when you extrude something, it asks you for a direction or a vector. So here we'll go to unit Z and then plug in that into it and then give it a number. So we'll go 1.5 for the height of each and every one of these. All right, so now that we have that, we need to create the top part that kind of caps it off. So I'll take this, disable preview. And now we need to create the surfaces between this one, between this one, between this one. So first of all, we'll bring in an item or a list item. When we plug it in and you see this is a grafted set. So we'll flatten it here. So we only pick one. And the trick on this one is under list item, we're going to pick not just one of the items, but we're going to add another one. Notice that it creates those two, which means that we can create a surface between those. So we'll go to boundary surfaces. But notice that this does it for the index of 0, which means it only does it for these two. If we wanted it to do it for the other ones, we could go 0, 1, 2. So we need to create more than one number to plug into the index so we can get all of those. With that being said, the way to do this is to bring in another series component because we need more than one number, right? And if we need more than one number, well, we need to know how much it steps by. So it starts at 0, steps by 1, and the count is 4 minus 1. And here's why. Because if we do 4 into the count, and then this into the index, and we graft this, notice that it creates 4 of them, and we only need 1, 2, and 3. It's creating an additional one behind it. So it's 4 minus 1. When you do minus 1, it'll create a subtraction with 1 as b, which means it'll subtract by 1. Now we'll do 4 minus 1 and into the count. Now, like I said, these values, we can hide them, don't necessarily need to see them, but I want to leave them here for you to see, just in case you want to understand all the numbers and how they work out here. All right, so the count, the surfaces. Now we'll bring back the extrusions. What we need to do is take these and move them up. But first, we're going to step these. So I'll disable the preview on the bottom ones here because we will need to use those. And now we're going to stack these into a pyramid. All right, so we're learning about the series component and how useful it can be by creating multiple numbers. And we'll be doing the same thing for this one. We'll be moving these progressively up by 0, whatever number, whatever number, whatever number. It's actually going to be the number that we extrude this by. So we'll plug in the extrusions into the geometry. The direction is going to be the Z direction. And the amount is going to be how much this extrudes, let's see, this offset. And this extrusion is going to be the same as the movement up. Notice though that it only moves it up by one number. So this is where our series component comes into play. Is we'll bring in a series component, use the 1.5 as the step, we will be using, let's see how many of them here. 0, 1, 2, 3. So 3 numbers. You can use this as a count. And so 0, 1.5, and 3 is what we'll be moving it up by. And let's flatten the input here, so that way it does this one, then this one, then this one, then this one. Notice that I actually need to bring in 4. Because this is 1, 2, 3, and 4. So now I'll disable the preview on this and bring back this one. All right, so on this one, what do I see? Well, this one needs to be moved up by 1.5, this one by 1.5 plus 1.5, and so on. So using this series, again, we're going to be moving. So I'll copy this one, and rather than moving up these, we'll move up these. Now notice here that it's at the wrong level here. It actually has to start at 1.5, and therefore all the other ones progressively go up. So let's do that. Let's take this and move it up, but it won't be using this one. It'll be 1.5 start. And from what I'm seeing here is we actually had 3 surfaces here, and this has 4. And I think the reason why is because this number, it won't be 4, it actually would be 3. So disabling the preview on the ground ones and on the rest of the stuff, you'll see that now we've created this pyramid, but the last thing we need to do is bring in this surface that goes all the way up to the top. Now the way to do this is we'll go back to our offset series of offsets, and we have to pick this bottom one here. So what I have to do is move or just pick that one. So one way to do that is list item, flatten the input, and reverse the list. It's not reverse. It's actually, if the index is of 0, this would be -1, which is the last one. And then this goes up by how much? Well, we know that this goes up by 4 times 1.5. And so if we multiply that, 1.5 times 4, I'll put this down here. Now this is the number that we're going to be moving up in the Z direction. This item. So move this one up here. Now turn this into a surface. So I'll go to boundary surfaces. Now we can join all of these together into a solid or into one open surface. So plug all these in, flatten the input, and disable the preview on everything except for maybe the initial rectangle. Now we can go to a custom preview to see what this looks like without transparency. So I like to use custom preview and color picker. And this will help us. Okay. Hide preview, hide input, Now you're seeing here that part of this is the ability to change the size of this, to offset this further or offset it less, right? This creates a step. This creates the number of steps, and which is definitely dependent on the original size, the original offset, because the larger the offset you're going to reach your limit earlier. You can see that visually here. Then we can decrease and increase the number here. And lastly, it's going to be the height of this. So this is an exercise that I wanted to show in simple terms how to create this. Why? Because I'm going to take the same approach that I took here, but it's going to be a little bit more challenging because this is actually going to be done on a dome or on a complex surface. So the steps might be a little bit different, but the concepts are exactly the same. And so I'll clean this up, and I'll also have this available for you guys that want to learn how parametric design works and how to get all of these different techniques into one script. So let me show you the other portion. Things that change. Then we have this is going to be the offset. Now, when you have a bunch of these wires that just go all over, sometimes it's okay to do that. I personally like to hide the wire display of things that are overlapping that look kind of crazy, just in terms of clarity. And the way to organize something like this would be select it, the middle one, evenly spaces them, and then right or left or center kind of centers them here. This is going to be number of steps. Also, here's another thing that popped into my head. These exercises are standalone exercises where you can learn a bunch of techniques, right? But this could in itself be a building design. Like this could be a pyramid design that you can start with. So sometimes techniques and exercises small like this can be independent form finding exercises. Like with this one, you know, we can change the size this way. We can create an array. We can go kind of crazy with this one. But the idea is simple exercises that you can learn various things. So here it's going to be height step. Maybe these shorter exercises are ones that I can just have available for free on my website for anyone to learn. Sometimes I do embed a lot of these exercises within scripts. So let me know your thoughts. I would love to know what's more convenient for you guys. I am a little bit of OCD with keeping these wires straight if possible. Then here to the right. And all right, so that kind of concludes this portion. Stay tuned for this next part where you'll learn a few other things on a complex surface. So thank you very much for being here. I hope you enjoyed this tutorial. If you want to download more resources, go to my website, capetti-david.com. There you can download this script and other resources that can be useful for those of you who are new or want to learn how parametric design works.